Hey guys, today's November 3rd, and here's a run through of our day. So you'll need your journal, pencil, glue, and your notes for 8.2. It is a 2-page notes. We went over Builder 10. We checked our homework. So for our homework, will be taking that for a grade. The one thing I am looking at is if you did your table correct, knew your relationship, if it was multiplicative or additive, and also if you did the ordered pairs. The graph was not really is what I'm going to be grading you on. I'm going to be grading you on the information, if you knew how to get the information and what it was looking at. So then we're going over 8.2 notes, which is rates, ratios, tables, and graphs. You have homework for 8.2. And our question for today is a Tasty Tuesday. So for all of November, we're going to be doing some stuff that's going to be thankful, what motivates you, what you want to see. Your funnies will be on Friday. So today is our Tasty Tuesday, and what was the best thing you've ever eaten at Thanksgiving? I got lots of green bean casserole, a lot of stuffing, turkey. Lots of people said turkey. The most interesting one was pink fluff, and it looks really good. This picture that one of the little girls showed us. So let's take a look into these notes. I'll pull up my document camera. Finding ratios from tables. So students in Mr. Webster's science class are doing an experiment that requires 250 milliliters of distilled water for every 5 milliliters of solvent. The table shows the amount of distilled water needed for the various amounts of solvent. So here we have our table right here. So we're looking at solvent and distilled water. So use the numbers in the first column of the table to write a ratio of distilled water to solvent. Now, do you see how distilled water was mentioned first and solvent was mentioned second? So just because solvent was on top of the chart does not mean it's going to go first. It tells us what order it's going to go in. So here's distilled water. We're going to put that first. So our first column was 100 to 2. So our ratio is 100 to 2. That's one way to write the ratio. 100 colon 2 or 100 over 2. So how much distilled water is used for 1 milliliter of solvent? So 1 milliliter is not on there, but that doesn't stop us. We can extend this table out, and I can put a 1 right there. So I can look and go, okay, well, 1 milliliter of solvent. Well, 2 milliliters is 100. Well, 1 is half of 2, so all I have to do is half this 100, which I would get 50. So how much water is for 1 milliliter of solvent? It would be 50 milliliters. Okay, use your answer to write another ratio. Use your answer to write another ratio of distilled water to solvent. So again, we could say 1 to 50. 1 colon 50 or 1. Oh, so sorry. Let me go back over that because I did not do that properly. It's supposed to be distilled water to solvent. See, even teachers make mistakes. That's why I like doing it in pencil instead of pen, but I like the colorful pens. So distilled water, so it would be 50 to 1. 50 colon 1 or 50 over 1. Are these ratios equivalent? Yes, they are. Okay, so let's look if I want to finish the table right here. So I know I went from 2 to 100 by multiplying by 50. So 3, I would multiply 3 by 50, and that would give me 150. Or I can say, well, 2 plus 1 gives me 3. So 100 plus 50 gives me 150. Now this is 3.5, okay? Well, I can make a half by dividing 1. If I divided 1 by 2, I get a half. And then if I divide 50 by 2, I get 25. So if 3 was 150 and a half is 25, my total would be 175. And again, you can multiply it by 50 and get the same answer. So if I look at it, I can see a pattern. Okay, so 2, 3. Okay, so I went from 100 to 150. If I get to 200, well, I just added 50 to it. So that would be 4. And 4 times 50 gives me 200. And then we would add 50 more to 200 to get 250 and add 1 more to 4 and you would get 5. So how can you use your answer in B to find the amount of distilled water to add to get a given amount of solvent? So to find that, we would take our solvent, just like what we did up here, our solvent, and we times it by 50, and that tells us, tells us how to find the amount of distilled water. Okay. And looking at E, if we're looking at the bottom part here at E, it kind of looks like the table right up here. So if we know 100 is 2, well, 3 was 150. 3.5, we found that to be 175. We found 200 was actually 4 milliliters of solvent, and then we had 250 plus 5 milliliters of solvent. So look for a pattern. When the amount of solvent increases by 1 milliliter, the amount of distilled water increased by, well, we went from 100 to 150. Well, that was by 50 milliliters. So if we look and figure out what 6 is going to be, so 6 milliliters of solvent requires, well, 50 more would be 300. So it would be 300 milliliters of distilled water. Okay, so real quickly, we talked about independent and dependent variables. So water, the amount of water depends on how much solvent you have. Okay, and because it depends, that is our dependent variable. So that is our dependent variable. That makes our solvent is the independent variable. All right, let's turn our page over. So representing rates with tables and graphs. So the Webster family is taking an express train to Washington, D.C. The train travels at a constant speed and makes a trip in 2 hours. Okay, real quick, guys. You will be starting this in the third 9 weeks in science. So this is an introduction in math, which will relate with science as well. So I want you to make sure we are paying attention here. So to find the ratio of distance to time is to find the rate. So distance divided by time, or distance over time. So we went 120 miles in 2 hours, which makes our rate 60 miles for 1 hour. So you're going 60 miles per hour that train is going. So if we expanded it into our table, our unit rate is to make the table. So really, our time is 1, our distance is 60. So that would be our unit rate. And then it would go, we can look at our table from there. So then we took this table that we had and made it into a graph. Okay, we took the time, which is your x, which is on the x-axis, which is our independent variable. Okay, and time down here is our independent variable. Okay, making our distance our y, which is our dependent variable, which would be y right there, do you see? And then that is our dependent variable. Okay, because the distance depends on your time. Time doesn't depend on your distance because time dictates how far you have gone. Okay, so that's a summary of our notes for today. Your homework is 8.2. One moment, you will find it in your Google Classroom. Okay, for some reason, Google Classroom is having some problems loading. So let's look at our page. So you are needing to figure out the amount of flavoring to add to the amount of water to make soup. So you're comparing packages of flavoring to ounces of water. So to find the rate of water we need for each package of flavoring, let's look. So I know that I have 24 ounces of water for 2 packages. Well, if I want to find the unit rate, I need to find 1 package. I would divide that by 2. 24 divided by 2 gives me 12. So it's 12 ounces of water per package. So I would multiply each amount package by 12. So 2 times 12 gives me 24, and I would continue on to figure out what it would be. What times 12 is going to give me 84, and so forth. And what times 12 is going to give me 144. All right, so use the unit rate to help you complete the table. Graph the information. Okay, so because packets dictates how much water we need, packets is going to go at the bottom, and ounces of water is going to go on the y-axis. All right, so you need to complete the rest of this. I'm really looking at 4 through 7. I want you to try your best on graphing. I know it's kind of hard if you're doing it on Canvas, but you're going to try your best and work it out. All right, so that's it for the day. Have a wonderful day, and I will see you tomorrow. Bye.